This will be a short lesson to introduce you to different sampling techniques, and this is always the start of statistics, where it's the very first beginning of any data collection or data analysis. Before we start, just pause this video, familiarize yourself with these definitions. So these are prior knowledge. What do we mean by data? What do we mean by categorical variables or quantitative variables? Population census, and so on. The focus today will be on sampling. So the idea here that you cannot, if you have a big population and you want to do a survey on them, you cannot actually access the full population unless you are aiming for a census here. So alternatively, you will have to take a small sample of the big population. The size of the sample, I'm saying small, but the size of the sample depends on what you're trying to achieve. And the point of today is to look at the different methods used to select that sample such that it's an appropriate sample that's representative of the population. So in any statistical investigation, you will always go through these steps. You will have a problem that you're trying to investigate, familiarize yourself with the variables that you're trying to look into, and then choose your sample. So that's the main focus here. How do you choose your sample such that it's a good representation of the whole population? Because you won't be able to access the whole population. So you need a good sample for that. Once you have the sample, collect the data, and then you organize your data in different ways. And you start to do some descriptive statistics and then interpret the statistics. So the whole chapter will follow this type of structure. And that's why we're starting with sampling now. So these are the different sampling techniques. These are the individual names, but sometimes some of these sampling techniques are merged together. So the most basic one is simple random sampling, and then we have systematic, convenience, stratified, and quota. We'll go through the definition of each one and then do a very simple question on one of them. So the simple random sampling, the whole point of it is that you allow the full population to have an equal amount of, and the same chance of being selected. And this can be done electronically or manually. The most basic explanation someone can give you is that you could put their names in a hat and just pick randomly. So that would mean that every person has an equal amount of chance of being selected. Another way is like random name generators online or so. So you would generate a certain sample size. So for example, your population is 100 and you want to select 25. So your sample size would be 25. So you would randomly select 25 people from different techniques. You could give them numbers and select 25 numbers. You can put their names in a hat or an online generator and then select that. So there are different techniques to approach those 25 people. Then we have systematic sampling, and comes from the word system. So you're approaching a systematic way of selecting the people. You would organize them, and then you would select the population at regular intervals. So for example, you would want to pick every third person, and then, or start from the third person and then move on every 10, for example. So you'd randomly have a starting point, and then from that starting point, just move every 10th person. Now what happens when you reach the end of the sampling and you still haven't selected the number of samples you want? You can then continue from the very beginning. This is useful such that it is random. Again, we're looking at randomness here. We don't want something to be biased. And it's convenient that you can approach everyone in the population. Convenient sampling, from the name, is that it's convenient. It's convenient for the experimenter. You could pick people that are easily approachable, people that you have easy access to. So that would be called convenient sampling. Then we have stratified and quota sampling. So the idea behind those two is that you are splitting the population into different groups called strata. So in the strata is up to you. you decide the category. It could be a female and male. It could be, for example, smoker and non-smoker. It could be their age group. It could be, for example, in this question, their year level in school. So you split them in different strata, and then from each strata, you randomly select a sample. So if you're aiming, for example, in this question, to get 25 people, you can just randomly pick 5 people from each, and then you'll end up with the 25 in total. How do you pick those 5? It could be using simple random sampling, for example. That's one of the ways. Or you want to do systematic sampling, for example. But the idea is that if you are randomly selecting the group from each strata, then it's called a stratified sampling. Now, if you are trying to select the people from each group, but you're trying to maintain the proportion of the population. So for example, year 8 students represent 10% of the full school population. So you want 10% of the year 8 strata, and so on. So we'll see an example right now. So if you've divided them into stratas, and then each sample from each strata is being selected based on a proportion, then that is called a quota sampling. So if you're specifically selecting them. So if you have a look at this question, you can pause, read it, and try it on your own. But part A then says, describe how you could use quota sampling to produce the results of 200 people. So they're already split into different strata. So this is a convenient group. I don't have any other information about gender or things to split it into another group, so I'm just going to use this strata. Now, if I want 200 people, and I want it to be a quota sampling, so I want it to be proportional. So from this group of people, I'll aim to select 116, and then from this group of people, I'll select 50. From this group of people, I'll select 24. And then from this group of people, I'll select 10. So that will give me the 200, but still maintaining quota sampling because the numbers are proportional to the population itself. So that's how you do quota sampling. Now, each sampling method has an advantage and a disadvantage. You can have a think through on what they are. Sometimes it's things like convenient sampling can bring in biasness. Things like simple random sampling, you might get no responses, so that's some of the issues that you might face. So each sampling method has an advantage and a disadvantage that you can discuss. Now, there are issues with biased or bad sampling, so not all types of sampling are good. Even the ones that we mentioned can have errors, especially if you're starting with a bad design. For instance. So even if you're doing simple random sampling, but the way you've selected the sample or the number of samples is incorrect, you're falling into some issues here. Other issues would be if you're excluding members from the sampling frame, like you're trying to do a certain age group and then you're excluding some. So in here, maybe you do have people above 55 that are still using Bluetooth headphones. So you're excluding them even though they're part of the population. There are issues with no responses. So those are like real life issues that you might face. So that's why sometimes you try and get a bigger sample so to account for the non-responses that you might face. And then there are some biases by the respondents in case, depending on the type of questions you ask. So this falls back to maybe a bad design in the questionnaire or the survey that you're sending out. Once you collect your data, there are some issues with data and the reliability of data. We consider data to be reliable if you can repeat the same data collection process and obtain similar results. We're not looking at exact, but similar results, similar trends. So how do we recognize that? That is done when we do descriptive statistics. We can see if there are any outliers or if everything follows a nice trend. So this is where we can see if the data is reliable. Data is reliable if it's sufficient also. There's no fixed amount for how much sample or how much data you need to collect, but it has to be a good representation of the population. Now, unreliable data would mean that you have missing data, for example, or you had an error in handling the data or collecting the data. This is it for the sampling. You can think through this question if you need to. It's a good way to see how you can select a sampling method that would be appropriate for this type of question.